using substitution. That's a system of equations, substitution. So what we're going to do is zoom in here on number 3. See how I have an equation that has x equal? So I'm going to take this, I'm going to get a different color here. This x right here, this right here, this is my value for x. And this is going to replace x in the second equation. So I'm going to do that. So go back here and get my black pen. I don't know where my black is. So I guess I'll stay below. And we'll do 3. I'm going to replace the x with the equation negative, or the expression negative 5y plus 4. And then I'm going to add my 15y. And that 15y is just this part of the equation. I'm going to keep my equals negative 1. Go ahead and multiply through, simplify this out, distribute, negative 15y plus 12 plus 15y equals negative 1. My negative 15y and my 15y are like terms, so I can add them. Well, they're opposites, so they actually cancel out when you add them on the same side. So I'm left with 12 is equal to negative 1. That's going to leave me with no solution. You could go put these two equations into Desmos and see if they intersect, and you should see that they are parallel lines and they would never intersect. Okay, let's go on to number 4. Number 4 here, we have two equations set up to y. So I could take this y value right here, and I can replace it in the top equation for y. So 4x plus 3 is equal to negative x minus 2. So to get my equation solved, now that I only have one variable, I can add my x to both sides to get it with its like term. 4x and 1x is 5x if you add those together. I'm going to add my plus 3, drop my equal sign, and these are 0, and then I have negative 2. Again, I want to isolate the x, so I'm going to subtract 3 from both sides. And I can add those equations together. And I get negative 5 here. And then x is going to equal negative 5 divided by 5, which ends up being negative 1. I'm not done because we have to find a place where these two lines intersect, which we know intersection points are found in an ordered pair, x comma y. I found my first part of my coordinate, x, which is negative 1. I'm still looking for my y. So I'm going to replace in one of the first two equations. It doesn't matter. One of those two. I'm going to take y, and I'm going to have negative x minus 2. I now know that x is negative 1. So I can replace the x with negative 1. Don't forget to drop that negative sign in front of the x because that is not part of the x. Now when we do the math, negative opposite of negative 1 is positive 1 minus 2 gets us negative 1. So it looks like our answer is negative 1, negative 1. You could always put this in Desmos and then see if this would work.